Hey guys, Tex here. Welcome back. In this video, we are looking at the third part of our flight series here in Orbiter 2016, where we are going to take off from the Earth here. We've already gotten into our parking orbit. We're going to arrive at Venus for a slingshot around Venus, back to Earth, where we will slingshot by the Earth and then end up out at Mars. So again, we are here in our parking orbit. Everything looks good. We're in a stable orbit, and what we need to do now is start planning our ejection burn, which is going to be about in 6 orbits away, I think it was. So what we're going to do is I want to see if we can use interplanetary for the ejection here to be more accurate, but of course we're going to use TransX for our slingshot plans. So that's already set up. You can see our slingshots all the way out to our final arrival here at Mars. And right now, it will be making several tweaks along the way, but we have a rough plan in place. I think what I'm going to do is let's see what we can do. First of all, let's get closer to the ejection burn, which is going to be in about 6 orbits. So let me just time accelerate. We're going to go around 6 times here. And by the way, I do have, that's one. I do have all of the realism settings turned on. So there's 2 orbits. So it will make this flight a little bit harder because you have non-spherical gravity sources and all of that good stuff on. So there's 3 orbits, 4 orbits. Let's just make sure we keep track of the time here. So our departure time is 432.6280, and we're close. I think one more orbit gets us there. Yep, that's gonna be the trick right there. All right, so we are about 1/4 of an orbit away from our ejection burn. So let's go ahead and get the ship pointed prograde. And while that's happening, I think what I want to do is to try and do this burn with interplanetary if I can. So I'm not sure if I can remember how to do this. I think what we need to do is probably pull up interplanetary on this side. We go to menu, course, and then I think we go to Delta Velocity program. And for this one, we're gonna believe we target Venus. Okay, and then I think I also need to go back here to configuration and set this to MJD. Probably need to change that in the configuration file, so I don't have to keep doing that. So we'll go back to course, Delta Velocity, Venus selected, and I think what we can do is simply come in here and plug in our variables. So our eject date is 55432.628. All right, let me get the vessel situated prograde here. I think we must be on the night side of the planet right now. It looks really dark. And just turn on prograde. All right, let's see. So I think we go to Delta Velocity Forward, which is essentially our prograde here, and this is where we set this. I believe we just do 2.939K. Okay, and then we go to Delta Velocity Plane Change. There's no outward in the plan, so the plane change needs to be 1.924K. And I believe that gets us there, 5312. Yeah, so velocity matches up. I think that's total velocity, that matches up. And then I think what we can do is come over here, go to interplanetary. I think we do menu, share, 0. Then we go to map. I believe we reference the sun. We target Venus, and we can do projection. I don't know what to set that on. I can't remember that one. Do we go to page? SOI. I think turn on the plan. Boy, guys, I forgot how much of this we're supposed to do here. I think we go to select. I'm supposed to see Venus, I think, over here. So I did something wrong, I think. That turns on the solar system. You can see the orbits of all the planets. So here's Earth. I think, no, this is Venus. Here's Earth. So we're here. We're trying to get over here to Venus. Something's definitely not right because I'm supposed to be able to select Venus and I'm not seeing that option. No, let's not center page. I don't remember, guys. Okay, well, I guess what we can do, we're not going to be able to, because I can't remember. There is a way, I just can't remember. I'll have to go back and watch my old videos, but it's deadly accurate. If we could get this map program, I wonder if I had that sharing backwards. Shoot, I can't remember. I forget it, guys. It'd take forever to remember all that. I have to go back and watch my video. So it would be deadly accurate, I believe, if we could use the map program here. But I think what I'm going to do is just I'm going to let it burn with these variables here in the Delta Velocity program, because that is the same variables that we have set up in TransX for our flight plan, which still looks good. Still looks good. Good enough. Yeah, I mean, our approach to Venus looks good there too. So I'm just going to run with that. So I think what we can do, since we are approaching the burn point, let's go back to this view. You know, relative inclination actually needs to be adjusted a little bit. So I think what I can do is when we get to the node here, I think I can do a burn right there. Let me just fast forward a little bit. And let's see if we can, ooh, there's sunrise. Let's see if we can do a small plane change here. I'm not sure if we can use translation. It might be a little too much for translation. Let's give that a go.
Translation.
Yeah, it's gonna be too much. So let's just use our main engines here. We're gonna do a plane change this direction. And I want to get that relative inclination right there to 0 if I can. Okay. Oh, that's good enough. All right.
Translation, rotation.
Let's point prograde again. And let me just check. That looks good. Okay. So according to TransX, delta velocity here is 3.767. And let me double check the variables, but I think Interplanetary should be able to do the burn for us, because I don't remember how to set up the maneuver in TransX from this point. It was only after we ejected Earth that I remember how to do that. So let me just double check our variables here. So plane change should be 1.924 and 2939. Okay, that looks good. All right, I think I'm going to run with that. So let's see. Now the next question is the date right? 55432. The date doesn't look right here. 55432.628. There we go. Okay, now that looks better. So those variables look right. No, still not right. Oh, I see, because we're at the ejection time. Okay, so let me do this. Let's go back. Let's go to maneuver mode. I don't even know if it was worth doing all this, but let me just do this for a second. And then let's adjust the date to our ejection point right there. Get it right on top of that. Oh, I did reset. Shoot. That's as tight as I can get it right there. So 55,432.6449. 55,432.64. I guess I would round to 5. Okay, that's good enough. So we are 300 seconds away from the burn. And Interplanetary is going to put in, it looks like 3.5K of velocity, which is a little bit less than what TransX is saying. TransX is saying 3.7. So we might have to finish the burn ourselves a little bit, but let's give this a go. This will be a first. Let me see. What do I do? What do I do? What do I do? We go to page, burn vectors. No burn vector. That's not going to work. Okay, that is not going to work. Well, let's see. The date's right, and okay, I don't know what else to do here. This is definitely got me stumped. So I guess we're just going to do it the old-fashioned TransX way, which means that we will probably be off by quite a bit on the flight plan after the injection burn. So we'll just go with that. All right. So can I use at least burn time though for this? Is it going to get that data from there? 3.766. It did. Okay. That'll work. The only thing is it doesn't get the vectors for the burn. And there's supposed to be some plane in the burn, and that's what I'm not going to be able to figure out how to do. Gosh, I just can't remember if I do a maneuver. I don't know if I have time to play with this. Let me just try this real quickly here. If we do enter -2939. That's not going to be enough. The date's fine. And then the plane change is supposed to be 1924. That doesn't look right at all. Something about that just doesn't look right, guys. 2939. It's the the velocity is right. Yeah, forget it. I know I can get there, but it's just not going to be. It's just not going to be as pretty. But at this point, it is what it is. Oh, we're burning. We're not even facing the right direction. That's cool. We're already starting things out right. I guess because I had burn time ready to go. Whoops. Okay, well, we are facing the right direction now, kinda. I think we're supposed to have some plane change here in the burn. So once we get pointed prograde here, I'm going to turn off the prograde autopilot. I think we are pointed prograde. So let's turn that off, and we're just going to let it burn. Watching relative inclination is hanging around 0, so I'm not sure what to do for the plane aspect of the burn. That's, like I said, that's what has me kind of scratching my head right now, because we're supposed to have this much plane change in the burn. So there's a significant amount of delta velocity that's supposed to go into the plane change of the burn, and I don't know if that was calculated into the launch when we launched or not. I'm thinking not. And I seem to recall that there was a number down here. Was it the semi-major difference? I think that's it. The semi-major difference and relative inclination is two things that you wanted to watch.
Translation. Rotation.
Let me see what happens if I rotate inwards. I think you want the semi-major difference to be at 0, and you want relative inclination to be at 0 as well. And relative inclination seems to be kind of ticking up right now. So pitching up seems to fix that a little bit. So I'm going to keep pitching in a little bit. Yeah, semi-major difference is coming down nicely now. We've done over half the burn, it looks like. So let's just go with that. Relative inclination looks okay. Okay, semi-major difference is coming down nicely. We're just about under 1. There we go. So let's bring this back around, pointed forwards here. This looks like a total Buck Rogers escape plan here. Okay, semi-major difference is really close to 0. So let's see if we can keep that at 0 and relative inclination about where it is. And we should be close enough. The question is the plane. The plane change part of the burn. Semi-major difference is, there we go. Went in a little too much there. Okay, we have escaped Earth's gravity. Relative inclination looks good. Semi-major difference is really close to 0. And we're just about done with the burn. Oop, go back in. Oh, right about there was the sweet spot. Okay, well, I guess that's close enough. Delta velocity wise, looks like we need another 50 meters per second. And we'll just clean the burn up as best as we can. See what we can do with semi-major difference. I'm not going to be too worried about the relative inclination. It's pretty much on 0. Semi-major difference is coming down. Delta V needs to go forwards. So I'm translating sideways and forward, which sideways is bringing down semi-major difference here. Okay, that's pretty much on 0. I think that's going to be close enough. So we'll just keep, I'm just translating to the right until delta velocity gets zeroed out. There we go. I think that's going to be good enough, guys. We're pretty much on track here. We won't know for sure until the way TransX works here. We won't know for sure how far off we are until we escape Earth's sphere of influence. So where are we at on the video? We are about 20 minutes in. So I think what we're going to do here is just coast away from Earth, enjoy the view. We'll get out of Earth's SOI, see where we stand and what kind of possible mid-course corrections we're going to be looking at before we wrap this video up. So let's just turn around so we can enjoy the view of the Earth instead of the sun as we coast away from it here. Speed time up. All right, let's go to the external view. And there is Florida right below us, right where we took off from. So that's pretty cool. You got the Bahamas over there. Got Cuba down here underneath of us. Very cool. Very cool. Let's do a little bit of house maintenance here. Let's see, we can... Is there anything we need to turn off? We probably don't need our nav lights on. Strobe lights, we'll leave the beacon on. And I'm going to run some timers as well. So we have this mission elapsed timer here. We are 9 hours and 27 minutes into the mission so far. So we're still in the first day, obviously, so I'm just going to let this run for now. But I think what I'll do is when we slingshot past Venus, I'll start this interval timer. And then when we slingshot past Earth, if I remember, I'll start this interval timer so we can kind of keep track of each leg of the flight. But yeah, I think this is going to be a good point to go ahead and save. Let me make sure we have our MFDs up for our save state here. Okay, so let's save that. And let's just coast away from Earth's sphere of influence. As I said, we can pull up the orbit MFD. You can see here I think it's called the G-field contribution. It's on 1 right now, so Earth is the dominant force of gravity that we are feeling right now. So we'll just kind of turn sideways and coast away from the Earth here. Okay, as we coast away here, guys, really amazing views of the Earth there. It's always so cool to look at that, just, you know, as you coast away from it, just departing it. What's cool about this flight, though, is we're going to be coming right back to Earth. Of course, we're not going to land, but we are going to get to come back and see Mother Earth here before we get to the red planet. So we're going to do a quick detour by Venus and then come back by the Earth. We'll probably be slingshotting by the Earth from a decent distance away, but we're going to be plenty close enough to get some nice views of it. So let's go ahead and fast forward time a little bit, and let's get out of the Earth's sphere of influence so we can go ahead and wrap up this part of the series. So I'm just going to quickly speed time up here. And, you know, I have no idea where the moon is. Sometimes it's a good idea to look around. There it is right there. So we're not in danger of hitting it. I think I did one flight before, a long time ago, I remember, where I actually hit the moon. It was like total random chance. So what are the odds of that? But I did a flight like this, ejected the Earth, and somehow, you know, I sped time up really fast and somehow managed to find the moon. And it scared the crap out of me because it happened so fast. All of a sudden it's and, you know, the vessel's destroyed, the alarms are going off. I'm like, what the heck happened? And then I realized I crashed into the moon. So the moon's over here. We're obviously we're moving outside of its orbit at this point. So you can see the G-field contribution dropping here. So let's go ahead and continue to warp ahead. So we are now very weak, influenced by the Earth as it's getting smaller and smaller and smaller. Let me kill that rotation there. All right, so there's the moon. There's the Earth. We have to get pretty far away from it. So let's go ahead and continue time warping ahead here and see just how bad we did with our ejection burn. All right, there we go. So, well, we're kind of in the neighborhood, but it is definitely going to require a correction. So we are here right now, and we need to coast down our trajectory like this. We're actually going to fall inside of Venus's orbit here. We're going to come around like this, and then we're going to rendezvous with Venus over here. So I guess what we're going to do is go ahead and end it here, and we will pick up the next part here. You can see that we're not close enough at all for the rest of our plan. So we're going to pick up the next part where we have to do a mid-course correction and coast out to Venus for that slingshot around that, and then head back to Earth for the slingshot around that to Mars. All right, guys, thanks a lot for watching. Really appreciate you tuning in, and take care. We'll see you in the next video.